today, but I like to do some research from time to time. And this time I wanted to deep dive into OpenAPI security. And just before we start, I'd like to ask how many of you are familiar with OpenAPI, either by doing some kind of security related with OpenAPI, or being a developer who at some point interacted with OpenAPI. Okay, so like half of you. There will be some slides where I will discuss about the basics of OpenAPI. So no worries if you don't know that anything about it. So today's agenda, I will discuss a bit about the background and how I ended up doing this research. Then we will jump a bit into OpenAPI analysis. What is the purpose of OpenAPI? Why is it important? And what is the attack surface? Then I will discuss about some of the research ideas that came into my mind while looking at the specifications of OpenAPI. I will present a small tool that I wrote in order to automate discovery of vulnerabilities, discuss the results, what I managed to find using this tool, and then a short conclusion and questions from your side if you have any. So, background, I don't know how many of you are familiar with Swagger Hub. I was not very familiar with it. I accidentally came across it while browsing the internet looking for the OpenAPI documentation of another product. But the idea is that they are hosting a lot of OpenAPI documentations, either for private or for public APIs. So if you want to see how an API works, maybe they have it hosted there. And when I say that they have a lot of OpenAPIs, I mean like really a lot of OpenAPIs, like 700,000. So as any other security researcher out there, when you see 700,000 of anything, you just want to download and start to look through them to see what is there. So I wrote a quick script and I went through all this OpenAPI documentation just to download them and then to further investigate them. And apparently they have already thought like people might be interested in doing this, and they put some filters and some rate limiting, but I still managed to get around 120,000 of those, which is 10 gigabytes of data, just to go and look through it. And after I got those, I started to write my own parsers to just extract what I thought to be some interesting information in those OpenAPIs, which are like headers, API locations, object types, passport, yeah, whatever. And I mean, this is something I managed to get a lot of data, and maybe something that I can use for fuzzing and share with the community, but it's still something not, I felt that there must be more in those OpenAPIs, you know what I mean? Like, there must be something there that I haven't thought about. So the question was, can we do better than just scraping and grab and apply some regex rules? And this is when I took a step back and decided to look a bit more in depth into how OpenAPI works and to do a proper analysis of it. So what is OpenAPI? OpenAPI is a specification language which helps us to describe how REST API works. It describes both the structure and the syntax of objects that are either pushed to the server or we receive them as a response. And what's nice about it is that it is irrelevant of the programming language in which the API was created, so it doesn't matter what it is on the backend, you are still able to describe how the API works using this OpenAPI specification. And maybe some of you are more familiar with it being called Swagger files. This is what it was called in version 2.0, but after OpenAPI Foundation took over, they upgraded the version 2.3 and changed its name. And basic points is that OpenAPI can be represented either in YAML format or in JSON format. And the question is like, why is OpenAPI needed? One thing is that you can quickly discover how API works. Instead of jumping straight into the code or trying to discuss with a developer, you can just inspect it and understand how it quickly works. And it's also a standardized way to describe it. So any developer out there or security researcher reading this should be able to understand it, how to interact with the API. So there is no need for us to understand how it was implemented. And this greatly improves both the design, the development, the testing of the API, so automation in one word. But to get to the point is that OpenAPI at the root level of the file, it has several interesting fields that we would like to look into. And for today's presentation, these are the paths, the components, and the security fields. So the paths part of the OpenAPI describes how, which are the API endpoints, for example, /get users or /books or host users or so on and so forth. So this is where those things are defined about the API. Then we have the components, and the components describe the schema of the objects that are being used by the API. For example, if you have an object, let's say user, this is described as having a username, a password, an email. So you can find all details about the objects being used by the API inside the components part of the OpenAPI file. And lastly is the security part, of course, because we are at the security conference. And the security describes how access control should be implemented at each of the API endpoint or globally. So you can decide if you want to do it granularly or globally. And here you can see how an OpenAPI JSON file looks like. And if you open it with a Visual Studio Code, and if you have the OpenAPI extensions installed, you will be able to see it on the left-hand side, the three components that I just mentioned earlier, the paths, the security, and the component, instead of going through the JSON text file by yourself. So once I found a bit more about this, I started to explore like what kind of tools are there available for OpenAPI. And there is this website called openapi.tools, which apparently has a great list of tools that both take OpenAPI as a file, as input, but also parse it or generates OpenAPI, so it does all kinds of things. And there is one section dedicated to security, so this is something that caught my attention. And I started to look a bit more like the tools that already exist over there, what are their capabilities and what can they already do. And most of these tools, you have to provide, for example, an authentication token, which will interact with the server. It will send some payload, it will analyze it, and tell you like if there is vulnerable or not. But my question was like, okay, but without having this authentication token, can we find some kind of vulnerabilities? Because what the tools were able to find was that it is missing a response code content for a specific endpoint, or the security flag was not defined. So those are things that can be easily found with grep or a regex rule. So I thought that maybe there is something more interesting to find in these open APIs, even without interacting with the API itself. So just to understand a bit better what is the role of OpenAPI in the development lifecycle, apparently I was also surprised because from my experience as a pen tester, I thought that OpenAPI would be mostly used in testing the API itself and maybe doing some publishing of the data or allowing other developers to interact with the API. But what caught my attention was that OpenAPI is also used during the requirements and the design phase of a development lifecycle. And most of the tools that I have seen in the OpenAPI tools website, they all focus on the publishing, development, deployment, and testing. And my thought was like, okay, but what about this part of designing how the API looks like and the requirements that are needed? Can we find some security problems at this stage of developing an API? So this was the starting point of my research. And some of the questions that came into my mind at that point was, can we use the OpenAPI documents to find design faults at the API level in the architecture of it? And what type of vulnerability classes would these findings be? And can I come up with some ideas or example of such attacks? And first thing that also was inspired by one of my pen tests, but I was thinking about it for a while, was something that I called an indirect broken access control. If we look on the right hand side, we have an endpoint which is like get writer, and it needs a new UID. and it returns some information about the writer of a book, which is also, and this endpoint is protected, let's say, by authorization or authentication, right? So the sensitive data at this point is stored in a in a person object where the address and date of birth of the writer is stored, but this looks pretty good for me and looks secure. And my question was like, okay, what happens when a developer accidentally adds an object that contains sensitive information as part of a public endpoint? So as a pen tester and maybe as a developer, I try to protect very well the get writer because I expect sensitive data to be there, and I add authentication and authorization there. But what happens when a developer is asked to add, for example, the name of the writer to as part of a response for a book, and then he accidentally adds the whole object? Is there a way for us to find if such a scenario happened solely by inspecting the OpenAPI documentation? So my idea was, let's try to find all objects that contain sensitive information in the OpenAPI, check all the paths from API endpoint that can reach that object, and then check for direct and indirect access. Because if we have an endpoint that is protected in order to access that data, we assume that developers want to protect something. But then if we find another path to get to that object, we assume that maybe developer forgot to add it there, because why would you protect it in one part but not protect it in the other? So this was one of the idea or concept that I came up with. And then I was looking at something like this, like inconsistent design, which is also sometimes mentioned in OWASP. And if you look on the right-hand side, you have a /get books, and then it returns some book ID, name, price, and person object for the author of the book. And can you say if it's vulnerable or not to any kind of attack? So the question is like, without context, we cannot say if it is vulnerable or not. But once we have the context of what the API endpoint should do, for example, if we have a description of what the API endpoint should do, which usually is provided by the developer, and the developer says that, okay, this endpoint should return the author's name, but then we look inside the endpoint and we see that it returns the whole object, then we have some discrepancy between what the developer said it should do and what it is actually doing. So another possible way to discover this would be to check the endpoint for input-output, and then to analyze the description that is also inside the OpenAPI, and then to determine if they match or not. And if they don't match, we might have some possible interesting scenario there. Another thing was like something I call IDOR, ID Finder. So in the right-hand side, you have like get user profile UUID, and I see this very often where developers assume that just because it requires an UUID, an attacker would not be able to know what is the value of the UUID, and instead of applying proper access control, they just let the UUID be hard to guess, and they will never actually check it more than this. So the question is, okay, developers do this, but how can we find such an attack vector? And the idea was to look inside also again the OpenAPI documents and find endpoints that require an ID and determine where this ID is also leaked inside other endpoints. So for example, if we see in one endpoint that it requires to have a UUID as part of the parameter, but the same UUID is returned in a response of another endpoint, then we know as attackers, I have to get the UUID from that response and use it over here, instead of us just trying to guess or find a UUID inside the application. So those were like 3 things that I was tinkering about while doing the research, but I wasn't entirely sure if I would be able to do it through using the OpenAPI analysis. So then I started to work on a tool that maybe can help us to do such a thing. And the characteristics of the tool that I wanted was to work on any OpenAPI, regardless of how the API is structured. So you give me an API documentation, of your API. I put it inside my tool, and I should be able to tell you if it's vulnerable to something or not, regardless of how you structure your API. And I also wanted it to be both visual and scripting. Visual because I'm a very visual person, and then I want to see how exactly does the data travel through the API, and scripting because I wanted to go like at scale and maybe scan all the 100,000 open APIs that I got. Or maybe if it's a very large API with thousands of endpoints, I want to be able to do this using scripting. And lastly, I want it to be easily configurable, so I didn't want to go into the code and modify the tool if you give me an API that I didn't expect. So these were the three main characteristics that I wanted from the tool that I was developing. And after a bit of Google, I found that there are some options. One was JSON schema-based object navigation, which already sounds complicated. So the problem was that this one didn't offer any kind of visualization. So maybe I could have navigated using a scripting language, but I was not able to see the data and how it connects. And another option was the graph traversal algorithms, like maybe depth first or other kind of algorithms like this. But then again, I thought that if I use one of these algorithms, I would be very stuck with the code and I would have to modify it over and over again. So I remember from other tools using Neo4j, which is a graph database like thing, and I thought like, yeah, let's give it a try, because I remember it was used by Bloodhound. I don't know how many of you are familiar with Bloodhound here. Okay, so Bloodhound is a tool in Active Directory. You tell it that I compromise this user and I want to know how to compromise this computer inside Active Directory. And if there is a path to compromise it, it will display you like what type of attacks you have to perform to compromise a specific computer based from the user that you already have. So it finds like paths between computers in a network, and it tells you like how to get there. So this is how Bloodhound works, and the concept for the tool that I implemented was similar to Bloodhound, but for REST APIs. So in my case, endpoints, parameters, objects, everything that I previously talked about would become nodes in the graph. And then when I wanted to look for vulnerabilities, I would have to run a Neo4j queries and see if there exists a path in this graph. So to start writing this tool, I was looking into how it is possible to upload JSON data on Neo4j, and surprisingly, for the first time in my life, I was actually able to find someone who covered this topic, and it wasn't a very long time ago. So I was very happy when I saw this article, and the guy explained that he already wrote some kind of converter that takes a JSON file, interacts with Python driver, and uploads the data to Neo4j. So this was exactly what I needed and I hoped for. And then I looked on the project on GitHub, and it has 2 stars at the moment. One is me and one is the developer who wrote that. So that was like, okay, I will give it a try, but I'm not sure about it. And at this point, like, my whole OWASP presentation was like based on this random article on Medium, but yeah, let's go for it. And the guy was explaining that there are 3 main parts, and first is it takes a JSON file as input for his tool. But the problem was like my JSON file was not the same format as his JSON file. My JSON file was OpenAPI, and he had a specific format to do that. So I wasn't even at step 1. I was at step -1 because I had OpenAPI, which had to be converted into his JSON, which then gets converted into a Python driver to get uploaded to Neo4j, and then I might be able to run some queries to look for some vulnerabilities. So this is how it started. I got his project from GitHub, cloned it, and then all he had there was like 2 objects, John Wick and Daisy, that were connected with 1 line. This was his whole project, and that was 100 lines of JSON code just to do this simple 2 objects and 1 line. And I was like, this took me 2 or 3 hours to get it running and upload to Neo4j. So hope was not very high at that point, but I started to add my own objects to this file, which was hard-coded, over there. So I started by adding, for example, an object, adding an endpoint name. So yeah, I just picked and did it like hard-coded in the JSON file that he had. And at some point I kind of understood like what his structure of the JSON file was. So I started to map like how I would envision the OpenAPI to be represented as a graph in Neo4j. And I had the option on the left and option on the right. The option on the left was the one that I went for. Not specific reason, but it was the good choice that I made looking back. And as you can see here, you have a node that starts with the endpoint. For example, it's the books endpoint of an API. And you can either post or get, make a post or a get request to this. So either you can create a book or you can read about a book. And this one will return an object book, which contains like fields like title, or it can contain another object, which is an author that at its own contains other fields. So it's a very basic representation of how I would like, I would have liked back then to look my OpenAPI representation. So I don't know if you remember from the beginning of the presentation, but I discussed about 3 main parts of the OpenAPI. It was the paths, the components, and the security. So I started with the components part, and this is the one that contains the objects. And here you can see how the components part looked. It had a lot of object names. So what I did was go through this file and extract each one of the objects name, and then create a node inside the Neo4j for each one of these objects. So this was quite easy, and I did it quite fast. So then the next step was look inside the object and then extract each one of these fields and create a node for each one of them as well. So the Neo4j graph started to look something like this. Once I did that, I knew that which object is connected with which field, and I could start to create the connections between the objects and the fields. And then when you zoom out, it started to look more like a galaxy or whatever, but it looked nice, and I continued to work on this. And one thing that I realized was that an object can contain either like a field of type string or integer, but it can also contain like an object on its own. So objects can contain objects. So at that point, an object would connect also with other fields, but also with other objects. So now the whole graph would start to look even more connected. And at this point, I had, for example, the possibility to write some Neo4j queries. And in this case, I wanted to see like how is it possible to get to a specific field, which is the starting point between an object and a field. So for example, I wanted to see how is it possible to access the merchant address field inside an API documentation. And in order to do that, I wrote an OpenAPI Neo4j query, and this one created the whole path for me. So in this case, I can see that it starts with a transaction object that contains a merchant, and the merchant contains a merchant object, which contains an address, which is of type merchant address, which contains the country. So this was the whole path that I had to take if I wanted to get access to this piece of information inside an API. So this is how the graph started to look after I added even more conditions to my scripts and to my tool. And once I finished with the objects, I started to look into the paths part. And the paths part, as I mentioned, contains the endpoints. So the endpoints would be /views, /users, and contains post and get requests. So similarly, as I did with the objects, I started to do the same thing with the endpoints. So it started to look something like endpoints are connected with different methods. And my code started to look like really messy because you have to put a lot of conditions like if this field is defined or if it's not defined. Because many of these fields are not mandatory. People choose if they want to add it or not, so you have to add a lot of if and else conditions. And then once I started to dive even deeper inside the endpoints and how they are structured, I realized that each endpoint contains like a request, a response, and parameters. And inside these ones, you can also have objects. So everything started to become like more and more complicated and more conditions. And This is when I started to contemplate my life choices. But somehow I managed to get through that, and I managed to connect the whole connection starting from an endpoint through the methods that are available, and then from each of the methods you either have a response, a request, or a parameter object. So the more I went through the OpenAPI files, the more connections started to happen. Here you can see I connected the request with the object that was necessary when you submit the request. Here you can see that I connected the objects also with the responses. And here you can see I also connected the parameters. So at this point I connected both the endpoints and the available objects in the API, and it started to look something like this. And when you zoom out, you can see that more and more connections are coming. And this is how the OpenAPI representation started to look. And then I started to have even more options in terms of like what Neo4j queries I can write. So, for example, in the first one, given like a field or an object, you have the option to see what are all the paths that can lead to that object. So, in my case, I wanted to see what are all the API endpoints that I can use to get access to the merchant address. So I would write something similar to that, and then Neo4j would come up with a path which was very hard for me in the beginning to understand. And I had to go into the code to see does this even make sense? Like, is this correct? So at that point, I think the tool became smarter than me because it could do these things much more faster than I could have if I went into the tool. Long story short, it was correct. And the path was fine. So, but in this case, you can see that it took like 4 embedded objects to see how it is possible to get to a specific field in the API. And this is a representation of how it is possible to access the money object inside an API. And here we can see that there are 4 different, not 4, but 1, 2, 3, 4, 5, 6 API endpoints that can lead to that money object inside your API. So now I had the paths and the components, and the last thing that I had to look into was the security part of the OpenAPI. And the security part, as I said, is enforcing like either have global security on the whole API or have security set at an API endpoint. And inside the OpenAPI JSON file, security is at the level of the API endpoint, and it looks something like this. In this case, it requires JWT token to be able to access it. And as I mentioned, it is possible to have security set at API endpoint globally, but if you have it set at the API endpoint, it will override the global security that you have set. So I did the same thing, the same process. This time it was only one object that I had to add, and this was a security object, and I would connect it to the verb of the endpoint if there was a security set. If there was not, then you wouldn't have a connection to a security object. So this was another example, like how it is possible to reach the task info object, and what are all the API endpoints that are available there to reach it. And here you can see that all post methods are connected to the security object. So in this case, authorization is enforced at all levels. And the graph started to grow even bigger at this point, and for only 120 API endpoints, I had already 1,300 connections in the graph. And I was a bit scared like it would crash at some point because it grows too fast, and spoilers alert, it crashes at 30,000 connections because I tried to see how long does it take until it crashes. So results. So at this point, I had implemented my own converter between OpenAPI and the data was uploaded to Neo4j. So what I wanted to do now is come up with a vulnerability scanner, to call it like this, which is a set of rules of Neo4j. But you can also have those scripted. So you either put it directly by yourself in the Neo4j, or you have a scripting language that will do it for you. And the scripting was something like this. It's very simple. You connect to the database, you almost take the Neo4j query that you have, you add it here, and then you get an object back, which is a very strange format of object, but you get an object back, and then you parse that and see if it has the path that you are looking for. So the whole concept was relatively simple. You start by parsing an OpenAPI file, and you get this OpenAPI file from the Swagger Hub website, for example, in my case. And then you upload this data to Neo4j database. And then you start to query the Neo4j for vulnerabilities, which are, for example, paths. And then you save those results. Then you clean the database, and then you start all over again with another OpenAPI file. So, I don't know if you remember the indirect broken access control. The concept was that we try to find all objects with sensitive information. Then we check all the paths that can reach this object, and then we see if there is a path that is authorized and one that is not authorized to reach it. So the pseudocode for this that I wrote in Sublime, I think it was, go for each one of the objects, get all the paths to reach that object, and for each of the paths, check if there is security required. And if there is security for one of the endpoints but not for the other, then we mark it as possible vulnerable. And in the beginning I started to run this and I wasn't getting anything, so I thought like maybe there is no such thing in OpenAPIs, like people don't make mistakes. And then people make mistakes. So I kind of found a lot of these things and I picked one of them. And in this case, you can see I have found an object which was called private profile object and a contact details object. And on the right hand side, you can see that there is one endpoint which has to provide authorization to access these objects. But on the left hand side, there is one endpoint that doesn't have to provide authorization. So in this case, we have a case where you can modify the private profile, both authenticated and unauthenticated. So it's worth looking into like why anonymous users can actually modify this private profile, right? And just to confirm this finding, I went into the OpenAPI file and I started to look for security objects, and this confirmed that one of the endpoints had security set and the other didn't have security set. So in order to fully confirm this finding, I would still have to interact with the API, but at this point I was already on a good lead on finding some vulnerabilities in the API. Another type of attack or things that I would look for using this tool would be paths to sensitive data. So what we want to do is find an object or a field that contains sensitive data, and then if the API needs authorization, check all the paths that actually don't enforce it, and then exfiltrate this data through the unprotected endpoints. So I also wrote the Neo4j query and the scripting part for it. I started to scan and I started to get some results from this. And in this case, I found an object which was a person, and this one contains some fields such as email and last name and age, so on and so forth. And when I started to look like what is the authorization for this, it seemed that it didn't have any. So I was able to access some sensitive information through unauthenticated endpoints. Another scenario that came into my mind like yesterday, it was to bypass the rate limiting, and the way you would do that is, let's say you have already found a field or object that contains sensitive data, for example, emails or phone numbers, and then what you want to do is list all the endpoints that reach this data, and then if it has rate limiting enabled, try to parallelize the requests. And I don't know if parallelizing is a word, but you get what I mean. So what I did was set the target point to the contact phone number and then try to see what are all the endpoints that can reach it. So let's say you have a rate limiting of 100 per hour, but if you create a script that will query each one of these endpoints, you can exfiltrate like 500 per hour because each one of them runs in parallel and each one of them has its own rate limiting thing. Lastly, it was the IDOR finder. The idea was to find endpoints that require ID and then try to see where this ID are linked. Unfortunately, I didn't have enough time to implement also this functionality, but some OpenAPIs have a thing which is called the link tag, and this link tag will tell you just by looking at the OpenAPI file where this value should be found inside other API endpoints. So to implement this one, it wouldn't be so hard, but I was focusing on other things and I didn't do it. Finally, conclusion. Parsing OpenAPIs is a complex task, like really complex with a lot of if and else's, but it's fun sometimes. The POC tool that I wrote is still buggy and sometimes it doesn't create all the nodes and all the connections, but I think it has potential to grow into something bigger. Neo4j queries can detect possible insecure design, so it can give you some leads on what and where you should look in the API. I don't think it can tell you like 100% that this is a vulnerability, but it's a good starting point. Manual verification for the findings are still needed at this point, but personally I think it's a promising technique to improve both defense and attacks of the API. Yeah, that's it. Thank you very much.
Yeah. Oh, sorry. Yeah. I guess somebody has questions. Now would be a good time.